Hi friends, in this video we will see the Wein bridge oscillator. Okay, Wein bridge oscillator is basically an RC oscillator. So in this Wein bridge oscillator we are using non-inverting op-amp, non-inverting op-amp, and we are using lead lag network. Okay, so this is the specialty of this Wein bridge oscillator. That means RC oscillators can be done with transistors. It can be done with op amps also. So maybe with RC phase shift oscillator, we have go ahead. We have already completed with R and C, combination of R and C, that is suitable for transistor type of thing. That means we can use any of the transistor topologies, maybe common emitter. We can use it in voltage divider format, and we can take the feedback from the output of the transistor and give the same thing to the feedback network. What is feedback network? RC circuit is the feedback network in RC phase shift oscillator. That part again we need to give back to the transistor. So this is what exactly happens in RC phase shift oscillator. But coming to Wein bridge oscillator, here we are using non-inverting op-amp and lead lag network. So how we are using these things we will see. Okay, once we get the circuit diagram, then we can easily identify this part. Yeah, first we have to draw oscillator. We have to draw the non-inverting op-amp. So this is my op-amp. This is non-inverting op-amp. So plus, minus and plus, and from this one a resistor is connected like this, and this is connected to ground, and again, and this is output, and this is connected to one more resistor connected to this part. Okay, and these are called offsets. Okay, and from this we have to connect one capacitor in the reverse direction and one resistor, and here also we have to connect one resistor and one capacitor. Okay, and this is connected to ground. Okay. And this, of course, this and this are connected like this, and this is my output V0. Okay, now I can write the names. For example, this is C1, and this is R1, and this is R2, and this is C2, so that this will be R3, and this will be R4, and this is my V0. Okay, this is VCC plus VCC, and this is minus VCC. Okay, the signal will be coming like this. It's a sine wave. Okay, now how to draw this as a bridge? So actually we need to take some points here. It is A, and here I can take it as B, and this point is C, and finally this point will be D. Okay, if this is the case, I can go ahead with drawing bridge here. So how to deal with this? So in between A and D, I am getting, in between A and D, I am getting, for example, first I will draw this. Let me have A here, and this is B, sorry, this is D, and this is, okay, that is up to you in which way you can draw. It's not an issue. So for my clarity, I am drawing like this, B. As we have already marked A, B, C, D here, so accordingly I am drawing, that's all. So A to D, so from A to D, I am having resistor and inductor. So from A, I am having resistor. After that, I am having capacitor. Like this. Resistor and capacitor. So from D to ground, okay, C is grounded. So from D to ground, I am having parallel connection of RC. So from D to ground, I am having parallel connection of RC. So this is my R, this is my C. Okay, Next, from C to B, I am having R3, R4. I am having R4 here from C to B, and A to B, I am having R3. This part, B to A, R3. So this is my R3. So now I can write this is R1, C1, R2, C2, and this is R4, and this is R3. So this is the way of drawing the Wein bridge. Okay. So now this is the Wein bridge, and how we need to go ahead with this. So this is like a Wheatstone's bridge type of thing. So this is Wein bridge oscillator. So according to those rules, we can proceed with the analysis of this circuit. Okay, we will go ahead with this. So what exactly happens if you see this circuit? It contains op-amp non-inverting in forward path. So for forward path, so what is for forward path? We have non-inverting op-amp, and for feedback path, we are having lead lag circuit. So lead lag network. So what does it mean by lead lag network? So this is forward path and this is feedback path. Okay, this part is feedback path. So in feedback path we are having two networks. So those are called lead lag network. So RC, R1, C1 are called lead network. So this particular part is called lead network, and this part is called lag network. So by using lead lag network, we are getting feedback. So that's all. So this is the circuit explanation, and even feedback resistors are also there, R3 and R4 from op-amp and lead lag network. So these two, so the feedback resistors R3 and R4 of an op-amp amplifier, and the lead lag network completes the bridge like this. Okay, so with these two and these two, they are forming one bridge. So what will happen if it is there? So at oscillator frequency, lead lag network designed to introduce zero phase shift. So this is the advantage. So lead lag network introduce. So this is the lead lag network. So this introduces. So lead lag network introduces 0 degree phase shift, and even op-amp also introducing 0 degrees phase shift. So some of these two are getting 0 degree phase shift. Okay, so this is the advantage, so that we can operate this particular thing for making it as an oscillator because it is producing 0 degree phase shift. Okay, so let us see the balancing conditions, how the balancing condition will be. Balancing conditions. So the balancing condition will be very simple. It should be R3 by R4 is equal to R1 by R2 plus C1 by C2. Okay, and the frequency is given by, the frequency will be equal to F is equal to 1 by 2 pi root R1 R2 C1 C2. So this is the frequency. For example, if we make R1 equal to R2 and which is equal to R, and C1 is equal to C2 and which is equal to C, then this frequency will be equal to 1 by 2 pi LC. Sorry, 1 by 2 pi RC. And what is the condition to get the sustained oscillations? So to get the sustained oscillations, the amplifier should be, the gain of the amplifier should be at least 3. So for getting sustained oscillations, the condition will be gain of oscillator should be more than 3 or equal to 3. Then 1 plus R3 by R4 is greater than equal to 3, which implies R3 by R4 is greater than or equal to 2. So this is the conditions. You have to choose R3 and R4 such that they should be with this relation. That means R3 is equal to, R3 should be more than or equal to 2 times of R4. Okay, like that you have to follow. So this is the explanation for Wein bridge oscillator. If you have any more doubts, you can put it in the comment window so that I can answer you within 24 hours. Thank you. Thank you so much. Please like this video, share this video with your friends and family, and kindly subscribe to my YouTube channel. Thank you so much.